let's talk about what if I rotate my complex number by an angle alpha. So let's say if I have, this is my Argand plane, I have one of my complex number here which is z1, and I want to achieve a second complex number which is z2 by rotating this z1 by theta angle. So here, since z1 is only getting rotated, what is the first thing that I can say? That modulus of z1 would be equal to modulus of z2, which means that my modulus of the distance from the origin is going to be r for z1, is going to be r for z2 also. So now if I rotate it by theta, what is my new complex number going to be? So my new complex number is going to be written as z dash is equals to z. So here z dash is basically z2, and here z is z1 e to the power iota alpha. Alpha is the angle with which I have rotated it. So instead of theta, let me take it as alpha only. So this becomes my new complex number after rotation. Now again, there are a few things that you need to remember. Let's say if my z is r cos theta plus iota sin theta, I can write it in the Euler form as r e to the power iota theta. Now if I rotated it by, let's say, alpha angle, so it would become r e to the power iota theta into e to the power iota alpha, because alpha is the angle with which I have rotated it. Angle of rotation. So from here I would get my final, or the angle, or the new complex number that has been rotated. It would become r e to the power iota theta plus alpha, and my new argument here is basically theta plus alpha. However, my modulus is going to remain same. There are going to be such cases where the modulus is also not same. Now of course that would depend on the conditions of the questions that have been given to us, but for your JEE Main syllabus you only need to remember these things. So let me explain it to you by taking two cases. Let me take the case 1, where my center is at origin, or my complex number, its distance is starting from the origin. So let's say if this is my Argand plane, this is my complex number z1, and this is the newly rotated complex number z2, and the angle with which I have rotated it, let's say it is alpha. Both have the same modulus, of course it is going to be r. So modulus of z1 is going to be modulus of z2 is equals to r. Now how can I write down my z2, which is my new complex number? It can be written as z1 into e to the power iota alpha. So keep this formula in mind. Now let's say if I take my second case, where my complex number is not starting from the origin, it has some other point from which it is getting rotated. Let's say this is my z1 here. Now this is my z2, and now I'm rotating this z2 with respect to z1 to get a new complex number which is z3, and I rotated it by alpha angle. Now remember one thing, that whatever rotation I'm doing this in which is in anti-clockwise direction. Now let's say if I do the rotation in clockwise direction, simply in my formula I'm going to put instead of alpha as minus alpha, because it is in the clockwise direction. So from here what I can say is that of course my r needs to be same for both these lines. So that means my z2 minus z1 modulus would be equal to z3 minus z1 modulus, and this is equals to r basically. And what would my new complex number z3 become? Basically my z3 minus z1, I can write it down as z2 minus z1 into e to the power iota alpha. Now of course if I need to find out only what my z3 is going to be, I can simply take the z1 to the other side and find out my answer. So this is how we find out for this case. Now few points that you need to keep in mind, that rotation is always in anti-clockwise direction. Anti-clockwise direction. If let's say my direction of rotation is clockwise, if rotation is clockwise, if rotation is clockwise, then my alpha would simply be taken as negative. So I would have to use the formula as z2 is equals to z1 e to the power iota minus alpha. So keep this thing in mind. Rotation should be always in anti-clockwise direction. Let's look at this example. Let W1 be a point obtained by the rotation of Z1 about the origin through a right angle in the anti-clockwise direction. So I have my origin here. Let's say this is my Z1 and I've rotated it by 90 degree to get new complex number, which is W1. So this is 90 degree and I've rotated it in anti-clockwise direction, sorry. So of course I can write down what my W1 is going to be. It is simply going to be Z1 e to the power iota into pi by 2. So I've gotten my W1. Now what have they told us? That W2 be the point obtained by the rotation of Z2 is equals to this about the origin through a right angle in the clockwise direction. Now again we have the origin here. Now I have a Z2 here and I've rotated it by 90 degree in the clockwise direction to get W2. So for this, what my W2 would simply become, I can write it as Z2 e to the power minus iota pi by 2. Very simple. Now what have they asked us? We need to find out the principal argument of W1 minus W2. So we need to find out the angle between W1 and W2. So first, let us write down what our W1 is going to be in terms of our Cartesian complex number. So this would become Z1. Z1 is 5 plus 4 iota into e to the power iota pi by 2. So this would become 5 plus 4 iota. What is my e to the power iota pi by 2? So if I write it down here, e to the power iota pi by 2 can be written as cos of pi by 2 plus iota sine pi by 2. So cos pi by 2 is 0 and iota sine pi by 2 is basically iota. So I would have an iota here. So this would become 5 iota minus 4. This is my W1. Similarly, let me find out what my W2 is going to be. Z2. What is my Z2? 3 plus 5 iota. E to the power iota pi by 2. Here there is a minus sign as well. So this would become 3 plus 5 iota and e to the power minus iota pi by 2. Instead of pi by 2, I'll simply put minus pi by 2. So I would have a minus iota multiplied here. And what would this become? Minus 3 iota. And iota into iota, this would give us plus 5. So this is my W2. Now we need to find out the principal argument of W1 minus W2. So let me just find out what my W1 minus W2 is going to be. I'll simply subtract the real part in both these W1 and W2 complex numbers. It is going to be minus 5 plus iota times of, I'll subtract the imaginary part as well. So it would become 5 minus this becomes 3. So this becomes minus 9 plus 8 iota. So how can I write down my principal argument for this? Theta, which is equals to argument, can be written as tan inverse of imaginary part upon real part, tan inverse 8 by 9. Now one thing that you must remember is that if I try to plot this W1 minus W2 in my Argand plane, you can see that my real axis value is negative. So it is going to be on the left hand side of the y-axis. However, my imaginary part is positive. That means it is going to lie in the second quadrant. And for the second quadrant, I hope you all remember what was the principal argument that we had studied. It used to be pi minus theta for the second one. So what my principal argument becomes? Principal argument is simply pi minus tan inverse of 8 by 9. So I've gotten this as my answer. So this is generally how you solve questions which are related to rotation. Again, very simple questions are going to be asked. This was also a question that was asked in one of the previous year JEE Mains. The only thing is that you had to remember that they had asked us to find out the principal argument, and W1 minus W2 was lying in the second quadrant, and for the second quadrant we have our principal argument as pi minus theta. So from there we get our answer as pi minus tan inverse 8 by 9. Now let's talk about the nth root of unity. The way we talked about the cubic root of unity, the exact same thing we are going to do here for n number of roots. Now let's say what if I have z to the power n is equals to 1. So I can write this as z to the power n minus 1 is equals to 0. So from here I can take z minus 1 common, and what would I be left with? I would be left with z to the power n minus 1 plus n minus 2 plus z to the power n minus 3, and this goes on up till I have plus z plus 1. This would be equal to 0. So this is one of our real roots, we know that. Now this one here is going to give us our complex roots. So how do we represent those complex roots? Those complex roots are represented as alpha, alpha 2, alpha 3, alpha 4 and up till alpha n. So this is the way of representing my complex roots basically. Sorry, it is going to be n minus 1. I'm going to have n minus 1 roots here, right? So it is going to be alpha 1 up till alpha n minus 1. Now again, the same concepts that we used in cube root of unity, those are only going to be used here. So let's say if I sum 1 plus alpha 1 plus alpha 2 plus up till alpha n minus 1, what am I going to get? This would simply be equal to 0. And you must also remember that alpha 1, since there are n number of terms, that means if I after nth power, what am I going to get? I'm going to get the same root repeated again. That means alpha to the power n. So for this case, this is one of the important points you need to remember. Another one is that alpha to the power n would be equal to 1. So keep this thing in mind. Now the general form of representing is going to be e to the power 2 pi I into k by n. Here we are considering that k is the number of roots. First we take 0, 1, 2 up till n minus 1. So explicitly if I have to represent the roots, so z0 is simply 1, which is my alpha 0. My alpha 1 would be e to the power 2 pi I by n. z2 would be 4 pi I by n, and this would go on up till zn, which would become e to the power 2 pi I n minus 1 by n. So these are certain things about nth root that you must remember. Again, even if you do not remember, the concepts that are going to be used are going to be same from what we studied in cubic roots. So you can take help from there and use them here. Now, when we studied about cubic roots, when we had 3 roots there, I hope you all remember there used to be an equilateral triangle formed in this way, right? And each point or each root used to be at an angle 120 degree from each other, right? There used to be 120 degree amongst each other. Now here what we have, since we have end roots and all these end roots are going to lie on the circumference of the circle, and that circumference of the circle, this circle would of course have radius is equals to 1. Now I would have roots here, 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 and it would go on up till n number of times. Now all these end roots, the angle between these two end roots, theta, would be equal to 2 pi by n. So this would basically depend on the number of roots that I have. Now if you try to replace this in the equation that we had for cubic roots, let's say if I replace this 2 pi by 360 degrees and n by 3, because we had 3 roots there, right? So 360 by 3 would give us 120, and that was exactly what we studied there. So keep this thing in mind. The nth roots of unity are evenly spaced around the unit circle, each separated by an angle 2 pi by n radians. Apart from that, the sum of roots is going to be equal to 0, and when all of this is taken to the power m, this would give us e to the power 2 pi I m k by n. Simply all the properties that we studied earlier for Euler's theorem can be applied here. Now let's look at this question to clear our concepts more. If alpha, beta, gamma, delta are the roots of the equation this, then what is the value of? So basically, if you look at this equation carefully, what have they given us? They've told us that we have our equation as x to the power 4, x to the power 3, x to the power 2, x to the power 1 and x to the power 0. This means that this equation had been, I guess, in this format: x minus 1, x to the power 4, this would have been the equation where x is not equal to 1. Now I am saying that because if x had been equal to 1, then I wouldn't have to solve this equation, right? So this would have roots as alpha, beta, gamma and delta, or simply I can represent them as alpha 1, alpha 2, alpha 3, alpha 4, doesn't matter. So from this equation, what is the one thing that you can see is that my n is going to be 5. I hope you are understanding this. My n is going to be 5, then only I would have one of my roots as real one, then my 4 of my other roots are going to be complex. So one thing we've found out from this equation, that n is equals to 5. Now simply what I'll do is I'll write down my alpha as e to the power. What was the value of alpha 1 that we studied right here? My alpha 1 used to be equals to 2 pi I by n. So this would also become e to the power 2 pi I by n. My beta, this would become e to the power 4 pi I by n. Right, from here you can compare it. So it is basically 2 pi I into n minus 1 by n. So again, my gamma would become e to the power 8 pi I by n. So, and my delta would become e to the power 16 pi I by n. So this is my alpha, beta, gamma and delta. So one thing that we already know from here is that whenever I take my values to the power 5, that means if I take my root to the power 5, it is always going to be 1, because it is a fifth root equation, right? So alpha to the power 5 would be 1. Similarly for all other roots as well, for beta to the power 5 would also be 1 only. This would be equal to gamma to the power 5. This would be equal to delta to the power 5. I can make this out from here. So now what if the equation that they've asked us, if I separate out the multiple of 5 in this equation? So I would have alpha to the power 2020 into alpha plus beta to the power 2020 into beta plus I would have gamma to the power 2020 into gamma plus delta to the power 2020 into delta. So this is what I'm going to have. Now since this is a multiple of 5, of course its value is going to be 1. So from here we get alpha plus beta plus gamma plus delta. This is the exact value that we need to find out. And we have already studied this, that the sum of all the roots of any nth root of unity is going to be 0. So we know that 1 plus alpha plus beta plus gamma plus delta, this is always going to be 0. That means what is the value of alpha plus beta plus gamma plus delta that I'm getting? It is going to be minus 1. So this is my answer. So I hope you must have understood this, how you are supposed to solve nth roots of unity. Again, if let's say you weren't able to understand that this was an fifth root unity, what other ways you could have solved this question was, you could have solved this biquadratic equation, find out your values of alpha, beta, gamma, delta, which would come out in this format, and based on this you would be able to identify that your 5 is the n, and based on that again the same things that we just did would be applicable. Now a few notes that you need to keep in mind. Again, triangles have been removed from your syllabus of complex numbers, so it is not necessary, but however still it is recommended that you remember these two formulas, so that if JEE asks questions related to this, you would be able to solve it. What is equilateral triangle property? Let's say if I have 3 vertices of an equilateral triangle, then they can be related in this format: z1 square plus z2 square plus z3 square. This is equals to z1 z2 z2 z3 plus z3 z1. And if let's say z0 is my circumcenter of the triangle, then 3z0 can be represented in this way. Again, this triangle that we are talking about here, this is still my equilateral triangle. So keep these two formulas in mind as well. So that was all about the theory and a few practical problems about this question. Again, as I mentioned earlier as well, JEE does not ask direct questions from this chapter in almost every paper. However, it tries to use the concepts in some other questions. So definitely a chapter you have to look into. Apart from that, the questions after this lecture that we are going to be looking at, the previous year JEE Mains question, you are going to be seeing that those are very easy questions that are asked. Direct questions, a few times when JEE has asked, those are very easy questions. So you'll see that the questions from this chapter are very easy and can be solved using the Argand plane or a few more other properties that we learned before. So let's start with the first question.